what we're going to do now is move on to some other types of cycles. So this one we're going to have to calculate the enthalpy change for the reduction of iron 3 oxide by carbon monoxide. That is what we have to write across the top. So let's just have a think what that is. So the reduction of iron 3 oxide, Fe2O3, by carbon monoxide to make iron. This is a blast furnace process. And it's going to make carbon dioxide. So why don't you have a go at balancing that equation? And to balance that you need 3 carbon monoxides and 3 carbon dioxides and 2 ions at the end. What's the data we've been given? Well, the data, it's got a little F there, so it's about forming. So when 1 mole is formed, so could you write an equation for the formation of that from its elements? When 1 mole is formed, could you form that from its elements? And could you form that from its elements? So pause the video and have a go at those 3. So there we are, 2 Fe and 1.5 oxygen gases gives me Fe2O3, a C and a half an O2, and then a C and an O2. They're my 3 equations. So now we have to look at what we need and where we've got it. Now the first equation we've got points to Fe2O3. So the first equation on our table has an arrow and it points to that. And it comes from 2 Fe's and 1.5 O2's. And that arrow is worth minus 822. The second number I've got points to a CO, and I've got a CO here. I've got 3 of them. Okay, they're 3. And there's only 1 in the table, but that comes from a C and a half an O2. Now I've got 3 lots, so I would have 3 C's, and 3 lots of a half is 1.5. Now I've already got 1.5, so I'm going to change 1.5. If I add another 1.5, I'll have 3. So I've now got 3 O2's and 3 C's, and I'm going to add on 3 lots of minus 111 because I had 3 lots of that equation. The next number in the table points at CO2. But we've only got 1 CO2 in the table and 3 CO2's here. So we have 3 lots of minus 394. Now you'll notice that there's no number for Fe. But again, if you go back to page 9 or 10, you'll see that for an element, the value is by definition 0 because nothing has happened. 2 Fe's have stayed as 2 Fe's. So we could say we've added 2 lots of nothing, if you like, because there's no change to it. And then we've taken account of everything across the top line. We've got the Fe2O3 here, the 3 lots of CO with the 3 lots of minus 111, the 3 lots of CO2 and the 2 lots of Fe doing nothing. We add all those up, and we get a total for each arrow. So this arrow is minus 1155, and this arrow is minus 1182. Can you work out what the value across the top would be? What would be the unknown enthalpy change? So I'm going backwards against that first arrow, so minus brackets minus 1155 plus the second arrow, because I'm following it. Work that out on your calculator. I got minus 27 kilojoules per mole. So let's have another go. We've got the equation that we're going to put across the top. So that's what's going across the top, but what have we been given? We've been given some data about formations. I'm just going to write these out as equations so I can understand them. Remember that formation is to make 1 mole. We'd make that from 2 Fe's and 1.5 O2's, and that one has a value of minus 822. The next thing in the table tells me that 1 MgO solid has a delta H when it's formed of minus 6 O2. That's formed from a magnesium. and a half of an oxygen, half a mole of oxygen gas. So that's the data in the table. And what are we trying to find out? So remember, we're trying to find out Fe2O3 solid plus 3Mg solid goes to 3MgO solid plus 2Fe solid. That's our unknown x. That's our equation that we're trying to calculate for. What data have we got? So the first bit of data we've got is making points, the arrow points to an Fe2O3 from 2 Fe's and 1.5 O2's. Okay? And that arrow has a value of -822. Now, the Mg's are an element, so if I was to put down here what they came from, they come from Mg. We can see that in a minute. If we just go to our next equation that we've got, we're making 3 MgOs. We're going to make 3 MgOs from 3 Mg's and 1.5 O2's, which we've already got. We've times in the equation by 3, so we get 3 Mg's and 1.5 O2's, and that points to MgO, but because there's a 3 in front, we have to have 3 lots of -602. Now the 3 Mg's here to the 3 Mg's there, we're not doing anything, 3 zeros there. And the 2 Fe's from here to the 2 Fe's over here, that's 2 lots of nothing, they're not doing anything. So this arrow is -822, and this arrow is 3 lots of that, which is -1806. Can you work out what x is? So I'm getting -984. So our final example's a tiny little bit different because we've been given a value for an enthalpy change here, just a regular thermal decomposition one here. This value here is for forming calcium oxide from 1 calcium and a half an O2 gas. And this value here is for forming a CO2 from a C and a half an O2 gas. Okay, so these are the values that we've got. And the question that we're being asked, so the thing that we're going to put across the top of our cycle, is to find the standard enthalpy of formation of calcium carbonate. So if I write that out, I need to form calcium carbonate. I'm going to form it from calcium, carbon, and 1.5 O2 gas. That's our unknown. So let's put the information from our cycle on here. We know that if we take calcium and a half of this O2, we can turn that calcium and half O2 into calcium oxide, -635. And if we take the carbon and the other oxygen, so we've used a half of the O2 already, but if we use the other oxygen, we can make a CO2, and that was -394. So we can add that arrow up and get -1029. We've also got a value right at the top, up here, for turning calcium carbonate into calcium oxide and carbon dioxide, so it points down, +178. So what's x? So we're following that first arrow, but we're going against that second arrow. And so you get a value for x of -1207 kilojoules per mole. There are plenty of Hess Law questions to practice in your study packs and exam packs. Have a go.